Hello, everybody. A huge thank you to everybody for joining us today. We're going to hold a discussion on a roadmap to working with your legacy code bases. This is a lead dev webinar created in partnership with Swim. The webinar is going to last approximately 45 minutes, after which both myself and the panelists will head over to the lead dev Slack. We're going to hopefully try and answer all of your questions there in the technical strategy channel, if you go to that. We're also hopefully going to have enough time to answer some questions live. So if you want to ask a question to the lovely panelists, please do submit that through the Zoom Q&A feature. What we're going to try and do is slot them into the discussion if I can as we go. But if not, then we'll try to get some by the end. But first, obviously, let's start with some introductions. My name is Sally Late. I use the pronoun she, her, and today I'm joined by Birgitte, Plum, and Tom, who will very kindly be sharing their experiences and their insights. And I'm going to ask each of them to introduce themselves. So Birgitte, could you introduce yourself, please?
Yeah, hi everybody. My name is Birgitte Böckeler. My pronouns are she, her as well. I'm based in Berlin, in Germany. I'm a developer and an architect. I'm working at ThoughtWorks, a global software consultancy. And recently I've been looking into AI tooling for coding, architecture, all of those things in particular. But I've been through a few iterations of legacy modernizations or legacy refactorings with our clients at ThoughtWorks.
Amazing, thank you. And I'm really excited to come on to some more details about kind of your work with the AI side of things as well a bit later. Plum, how about over to you now?
Howdy, I'm Plum, pronouns they, them. I'm a senior director of engineering at Rowe, which is a telehealth firm based out of New York City. I'm based out of Jersey City, same thing, just across the river. Similar to Birgitte, I've deprecated a bunch of stuff. I've definitely written some legacy code for sure. Sorry about that if you're still dealing with it. And I'm always really glad to have a conversation with this community in general.
And Tom, over to you finally. Thank you.
Thank you, Sally. So I'm Tom. I'm one of the co-founders of Swim. Big fans of lead dev. Have been working with lead dev for a while now. So happy to be here. We started around 5 years ago, and what we do is help engineers and engineering organizations understand their own code. And what we found over these years is that nowhere, is there a problem worse when you're dealing with legacy code. So we're helping by generating documentation, keeping that documentation up to date, and generally helping folks with code discovery and understanding what's going on before they either maintain or modernize or whatever they want to do with that legacy code. So working with a lot of types of organizations, but a lot of common problems.
Absolutely. Well, thank you all so much for joining me here today. So in terms of kind of framing the conversation that we're going to have, we know that working with legacy code is consistently a top source of dissatisfaction for developers and leadership alike. When it comes to developers, they want to work on cutting edge feature development, not necessarily get, kind of bogged down in unfamiliar and poorly documented code. Leaders want to move fast. They don't want to be slowed down by needing to kind of, constantly work through legacy code issues when they're wanting to ship the new shiny things. So what we're hoping to get out of today in this discussion is some really practical advice for everybody listening, to help make legacy systems approachable for developers. Hopefully through that, we can then improve productivity, improve developer satisfaction. But when we were kind of thinking about putting this together, I thought it would be really important, because legacy in itself is quite a sort of ambiguous term. So how do you define a legacy code base? When does a code base become legacy? Plum, would love to get your thoughts on that to kick us off.
Yeah, sure thing. I sort of divide legacy code bases in my mind into two different categories. One is where the actual application functionality, like that is the shiny feature, but the tech that's under the hood is way less shiny, is way rustier. And whether that's actually a stack that we don't want to use anymore. The framework's become deprecated. It's no longer maintained. Or it could be, it is using a modern stack and then a bunch of special sauce on top that someone else has built that now is no longer documented. We don't know how to maintain. So that's like the one category, is just the pure technical. And the other is sometimes the actual tech stack is solid. The patterns are solid, but the business case application logic has become outdated. It was maybe built too narrow with a lot of hard-coded assumptions. And I've worked in a couple startups, so I've hit this many times. And suddenly we get to a different stage of the business where the initial assumptions no longer make sense. And we continue hitting these limits in our core application as we're trying to scale. So in some cases, app is great, tech is a little rusty. Other cases, app is rusty, tech is fine. And if both, then that's very legacy.
Very legacy. Birgitta, you work with a load of kind of different companies, different people in your role. Have you got a different take on this, or do you feel similarly that it can kind of be boxed into those two different or three different approaches?
Yeah, I would also say that at least in the context that we use the word legacy, right? It's interesting because in other contexts, legacy is actually a good thing, right? Like something is like a big legacy that somebody left, or, in a positive sense, right? But in this context, like usually we use it to say that we need to do something, that we need to clean something up or make something better, right? And usually that's when it is starting to become hard to maintain, and like changes are taking a long time, or way longer than they used to, or way too long for the business to accept that, right? And one distinction I really like is this distinction between accidental and essential complexity. I think the term originally comes from one of the essays in the Mythical Man Month collection of essays. So kind of legacy for me is when the accidental complexity is getting out of hand, right? And I also see that often when people approach improving a legacy code base, that developers get hung up on all kinds of complexity, right? Even the essential complexity that might be there because the business needs it, right? And so you have to distinguish between the things that are accidental and the complexity that we really need, so we can preserve that and make it maintainable in a way. So I think when the accidental complexity is getting so out of hand that changes are taking a really long time, that's one of my definitions.
No, fantastic. Thank you. And that takes us really nicely into what we could perhaps consider the start of this process. So when we're thinking about legacy, when we're thinking about modernization, removing that burden starts with understanding what we have, what the code does, why it is that way as well, I think is always a really interesting thing to poke around with. So what tools, what techniques do you all use for code understanding or sort of code discovery? Tom, I know this is an area that you care about a lot. So wonder if you could share your thoughts on that with us.
Sure. So specifically, if we're talking about modernization, there's no way around ultimately having a stack of documents that describe what the application needs to do from the business perspective, from the product or the user perspective. That you need to get to that point, and you need to understand all the functionalities, or else you're going to miss very significant things. The way to reach that point, it can be super complicated depending on the situation that you have. If you have folks in the organization that do know the code well, or if those are long gone, which might happen many times. But even if you have folks that know the code base well, a lot of the work still needs to be done by people that don't. So even before getting to the point where, if you could start just by writing what the application does from a business perspective, that would be amazing. But you actually need to go through understanding what the code is doing, right? And particularly edge cases and weird stuff that's going on there. And if we're talking about things that were written a long time ago, you're caught in really bad naming conventions. You might have a team that don't really know well the particular stack or language that's being used. So you need to actually write down a lot of your insights going through that code, either the developers that know it or the experienced ones that go through it. If you try to go around that part of writing down what the code does, how it works, then you're going to end up making a lot of corrections, sometimes over years and years. So you don't want to try to go over that point. And of course, we're helping by automating a lot of that process, but we're meeting all these companies that don't have that option. And specifically people think about old languages. They tend to think, okay, so now we have all these fancy tools like ChatGPT, so we can just feed them this function and it'll tell us what it does, and that'll be fine. But actually, it's just a superficial solution. You need usually a person to explain the really complicated flows that go through various different parts of the code base. And then you need to add the technical or business context to those flows so people understand how they match with what the application is actually doing and why. So I don't want to, get too much into how we help to do that. That's what we do, right? But I simply want to state that you can't just walk over that part and move on and just start with the fun part, which is explaining how the new application needs to look like.
No, thank you. And I think it's a really, really good point in terms of making sure that you invest in these things rather than just diving in and jumping to the fun parts. I think that is a really, really great tip for everybody. Birgitte, do you have any thoughts on this as well?
Yeah, I would maybe say something about like beyond functionality, right? That's one part about like knowing the functionality, right? Especially if you want to write a new application from scratch. But a lot of people also want to do like a step-by-step evolution of the code base, right? And then it's, for example, really important to know what are my hotspots, right? What are the really risky parts? And one thing that's really interesting to look at there is things like Git history and looking like where do we have parts of the code that nobody knows, or, only this one person ever touches, or, what are the parts of the code that get changed all of the time, right? So that's an interesting data point I always find. There's like a bunch of tools out there that help you analyze the Git history, and it's also language agnostic, which is nice. So you don't need a tool for every single tech stack. And another thing to look at this with hotspots and stuff like that is like an approach that I really like is a company in Australia, REA. They wrote blog posts about this and gave talks about this to kind of have like a health standard for your architecture or your different components, right? And have kind of like a lightweight, almost like inventory that really tells you the health state of each of your components and really having an agreement of what health means. And then you have like some really good discussions that are not about tech debt, but they are about health, right? So you can talk to product about the health here that we agree to is really low, and that's a big risk for us. So we need to invest in this part in particular, right? So this kind of like lightweight inventory where you really have a good agreement between tech and the product side as well, and the business side of like what good looks like and why you need to invest where. I also find a really helpful type of visualization or catalog.
I love that framing as well. The health standard is a kind of much more positive spin on things than
exactly, yeah,
and that can be helpful,
yeah.
I think, in having those conversations, presumably.
Yeah, and it gets us out of that death spiral of like nobody wants to hear about tech debt anymore, right?
Yeah.
So maybe we need like a new way of talking about this with each other.
Rebranding, yes, yeah. Absolutely. If you have that link, I think it would be really, really interesting if we could sort of post that in the Slack channel afterwards. I think I'd personally like to go through that in a bit more detail. Do you have any tips, though, if you do find going through the Git history, stuff like that, where there is only one person that's ever touched something and they are no longer with the business? What happens in those kind of situations? How would you kind of do some of that discovery if that was the case?
Yeah, I think then that would get us back to some of the things that Tom was talking about, right? I think it's also not always a problem if it's like a component that hasn't been changed in ages for a reason because it's not that important. Then it's just one indicator, right? So if you find that that is the case for something that's really important for you, then that's a problem maybe, right? And then you need to invest in like other things like how do we better document this? How can we make sure that we can change? Do we have tests for this? If there are no tests, that would be a big risk, right? So it's like always multiple indicators that determine where the risky parts are and the dirty parts that you should clean up and the dirty parts that you can leave as they are.
Amazing, thank you. So moving on then, if we've done the hard work, we've done some discovery, we understand where our hotspots are, our health standards, where we're actually coming out. What are your approaches then to move into the actual modernization itself for the code? That might be refactoring, it might be other kind of elements. I'd love to hear a little bit about what kind of processes you work through, if you've got any tips, or if there are any kind of, again, must-dos at this stage to help set you up for success. Plum, could you start us off on this one, please?
Yeah, definitely. I think very early on, once you understand how the application works now, is a good time to also pause and make sure we have a good understanding and alignment on what the application should look and feel like. Is it actually going to be one-to-one functionally, or is there something we don't like about the function? This is the time to propose and change it. The worst thing we can do is rebuild the thing we don't like in a different language. So we haven't really accomplished too much in terms of making our development experience better. So if we already have the opportunity, we're under the hood, that is the time to really be doing some tuning. And it's a delicate balance. You don't want it to turn into an infinite scope creep of it just cascades and suddenly we're rewriting the entire system from the ground up. But we also don't want to sink a bunch of time if we really feel that there's a part of the application that is just not servicing us in the way that we need it to. Going along with that, and folks who work with me know I always joke, like, just delete the code. That's the solution to everything. Then there are no problems. In some cases, though, I will say it's important to not get caught in the biases of the current system. So don't be afraid to delete something. Obviously, there's a technical process to making sure as you're deleting something, you aren't losing functionality, but don't get stuck in that. This needs to exist because we've always done it that way, and therefore it needs to exist, because that's how you end up creating a slightly more modern, but still kind of legacy code base. And then the only other thing I would say in terms of some of the process side and getting the buy-in, and I know we had mentioned the idea of calling this a health metric or moving away from the idea of migrations and tech debt. The sooner you can rebrand that, the better, because these are big investments. They're going to take a lot of time, and you're going to not just get stakeholder buy-in at the beginning, but throughout the process, remind folks of why we're continuing to do this, because we don't want to lose momentum and steam halfway through and then never get through to our goal. Your product lead is never going to come to you and say, like, our biggest business opportunity in Q4 is GraphQL. Like, let's do it. So we have to be the ones who are really continuing to drive that momentum, continuing to remind why it is important for the features we want to unlock, for the things that we've been stuck and continuously slowed down building as we're going through this migration. So it's a bit of the marketing side and a bit of the like forward-thinking product development side on top of all the technical.
Yeah, absolutely. I love that in terms of just delete the code. That solves all the problems. Get it out there. No code at all. No legacy, no debt. Amazing. Great. Well, any other points from you other folks to chip in on that? Or should we move on to something a little bit spicier maybe? No? Okay. So tied into this in terms of the discovery side, in terms of the modernization, I'm going to say the buzzwords that no webinar is complete without, AI. I know it can be a divisive topic, but if any of you have used AI for working with legacy code, I would love to hear a little bit more about what you would consider its strengths, where it's going to work really well for people, and what are the potential weaknesses as well? Because I know that we're all looking for, efficiencies. We're all looking for ways that we can work a bit smarter or be a bit more intelligent about how we spend our time. But there's obviously a lot of different factors that go into legacy and modernization, as we've been hearing. So yeah, which are the bits where it works really well, and where should we be a little bit more wary, perhaps? Plum, would you like to sort of follow on from what you were just sharing with us and go into that side of things?
A little bit. AI is very interesting in the space that I work in particular, which is telehealth, in that we have to be very sort of cautious about when and where we're plugging in some of that. Even when it's just the pure code base, there's a process to go through there. I would say the strengths are that, to some of the stuff that Tom mentioned before, it's just very easy to parse a large set of information to try and start getting summaries. And, if have the right permissions, we can have that be something we're using. I've also found it really great in pure syntax ports. So if you're doing something that's like enzyme to React testing library, was something I think a bunch of us have done recently. And that was a pure, hey, Chat GPT, take this function, convert it to a different function set. Like that helps just, and you can do some fun CLI stuff and sort of blast through a bunch of files like that. Yeah, but then the weaknesses come in some of the context setting piece.
Absolutely. Birgit, I know this is something that you do a lot of work in, or that's my understanding. Please correct me if I'm wrong. What's your take in it? Because I feel like it's probably a little bit different to Plum's experiences here as well.
Yeah, it's basically been my role in ThoughtWorks for the last like more than a year to try and like keep on top of everything that's coming at us there and talk to people on teams. And maybe I can talk about three different things. One is, I mean, yeah, we have to remember that at least at this stage, who knows if it will ever get beyond that, it's an assistant, right? So we have to think about the use cases where the AI assists or this type of AI, generative AI, which is non-deterministic and hallucinates, you know, even if you can reduce it as an assistant. And one area where we've done that is to help with the reverse engineering. So when you really have a code base like that, it's COBOL or something where you really don't have anybody there to help you understand it, you often have reverse engineers sitting there for weeks sometimes writing reports about what the code base does, right? And we found at a client where we've actually done this that you can that we could actually generate a report about what a COBOL module does that usually 2 reverse engineers would have needed 4 weeks to actually create that report. And it was good enough for the subject matter expert that usually signs off on those reports. So that's one area. So kind of think about it assists in reverse engineering. It doesn't turn the code immediately into the target code, right? This type of thing. And then another thing I tried is I took like kind of like an old open source business application code, and I tried to solve a ticket for this open source code. And I found two things there. One is that with understanding the code, it was actually really good at pointing me at the right places, like, and helping me understand some of the domain terms even and find where I need to change something. But then on the other hand, when you think about like an old code base, this was Java 8. It was still running with VirtualBox and Vagrant. I don't know if anybody remembers that. So I also had to set up this code base and actually make it run, right? In like, you know, combination of multiple different like older pieces of tech and newer pieces of tech. So AI also, or Gen AI wasn't that great at helping me do that without like good documentation that was already there. And then the other thing was, when I want to change something in an unfamiliar code base, I need to reproduce the current behavior and I need to feel secure in changing it. So I want a test, right? For example, to reproduce it. In this case, the class I needed to change or the function I needed to change didn't have a test yet. And a lot of people are interested in, oh, I have this old code base. It doesn't have any tests. We need to change it. Can we use AI to generate tests, right? And if there are some existing tests already, then maybe. But if there are no tests, then probably the code is not unit testable yet, right? So, and this is what I was running into here. So there were like really big input objects. I kept running into null pointer exceptions when I was trying to set up the test data. So this is something, you know, if there's nothing there yet, the code doesn't support it yet, then, you know, AI also cannot help me build up those tests, right? So it was kind of mixed, but especially with the understanding, navigating, reasoning about the code base, it already works quite well. And I think there are technical ways to make this even better that Tom maybe even knows better about than me.
Sure. So taking it from here, so we've spent the last 2 years trying basically everything, I think, at least relating, not to writing the new code or translating, but understanding the code. And before, I don't know, GPT 3.5, the way we work was purely static analysis. So purely deterministic, iterative method, right? Like the opposite of working with LLMs. And with LLMs coming in, and particularly GPT-4, there was a lot of excitement. So I thought I could, you know, say something about pleasant surprises and also disappointments. So the first and kind of obvious disappointment was that you cannot just take a whole lot, no matter the context window size, you can't just take a whole bunch of code, feed it into an LLM and ask it to do almost anything. That it really sucks in that. And so immediately we're interested, okay, we still need this deterministic approach to first create insights and then feed those to the LLM. And then those two together are really magic. Because what LLMs are really good at is taking something that's super, super technical that you would get out of static analysis that you run to understand a particular flow that's really complex, feeding that to an LLM and then telling it, please make this into a document that would be pleasant to read. They're amazing at that. So disappointment that led to a pleasant surprise. Another thing is that with some of the older languages, so Birgitta mentioned COBOL, and it sounds like it worked well, but COBOL actually has a lot of dialects, and also there are other languages, and depending on the model, some models just weren't trained at all on some of these. So, but you're not aware of that. You don't know that for sure, particularly because sometimes it treats the computer language like actual language. So sometimes it gets things right, particularly if the naming convention was good. So it kind of feels like maybe it does understand the language, but actually it doesn't. So then you give it, more complicated tasks and it fails miserably. So again, getting back to using static analysis, having something that's deterministic that you can iterate on, and only then feeding that to an LLM and translating it, if it's a language that it has no experience with, translating that to something that it can work with, then works much better. One other pleasant surprise was sometimes you have situations where the naming, particularly with COBOL, naming conventions are totally terrible. And like you have a program called CP124. That's all you know about it. And then how do you try to understand the business logic behind this thing, right? So in some cases, we found that if you feed into an LLM several examples of how that program is used, it can sometimes give you like a guesstimate of what this thing is doing. Like this is actually, in fintech, you tell it, this is a bank, right? So what is it doing? Oh, it's probably calculating this type of thing, which is pretty amazing, right? It doesn't work all the time, but it can save sometimes a lot of sometimes days of work.
I love that. I'm totally going to bear that in mind for the future. That is a very practical tip for me. Thank you. And I did just want to build on something that you said there about LLMs being great at kind of taking a load of inputs, being able to smush it around and spit out something that is very, very readable. When it comes to legacy code bases, there can be other factors outside of just the code itself. So there can be, kind of debt that has been accrued in the documentation, as we've talked about. There can be knowledge, confidence gaps in terms of, people who have left, like we said. Do you have any tips around that side? So not just, the code side, but around the, everything on the fringes that can give you confidence in the actual kind of modernization program itself?
Yeah. So two things. First, it really is different if the goal is modernization or just maintenance. Though, even if you're going through a modernization process, that might take 5 years. So as you're going through that modernization process, you are still maintaining a lot of the things, right? So, but specifically for modernization, I think it's important to realize that ultimately you need a document or documents that describe the flows in a business language, in a product language. And there's a challenge there because you're using engineers that know or have a capacity to know this code well. They're not necessarily the perfect people to then translate that to a business language or product, manager language. So you have to be very aware of that. You probably need couples of people that work well together to be able to do that. On the maintenance side, something that people often neglect to think about is why documentation sucks in the first place. So one of the, and as you're writing it, it's important to know that. So from our perspective, the core problem with documentation is that there's no system to keep it up to date as the code changes. And if you're writing, and if you want to maintain legacy code, what you want to do is write documents that are very in-depth and explicit and helpful. Those are exactly the kind of documents that when the code changes, they also need to change. So this is one of the things we do. So naturally, I'm going to talk about this, but also we do this because it's been such a problem. So either you have an automated system to do that, like what we provide, but otherwise you always need a system or a process in place to make sure that as you're writing these documents, you also have something in like some sort of process in place to make sure every once in a while that you go back and you see if these documents need fixing. Otherwise, you're going into a trap, because people are going to read these documents, they're going to notice that they're outdated, and then they're not going to trust almost anything that's written there, because it just takes one experience where they go on a wild goose chase because of something you wrote that isn't true anymore, and they're like, this is wasting more time than it's saving me. I might as well just go in the code and try to understand it myself. And then all that effort it just goes to waste.
Yeah, absolutely. And when you're talking, I couldn't help but glance over to one of the questions that's come into the Q&A box, which I'll come on to in a sec, but there's so much that goes into this, right? So there's the actual kind of coding work, there's the documentation, there's all the bits around the fringes. So the question that's come in is from Vidya, and asks, how do you approach tech migrations in the context of a business that needs the engineering team to keep delivering new features? What are some of the most successful mechanisms you've used to weave tech debt related changes into an overall product roadmap in a way that gains and retains business buy-in? I wonder if any of you might want to take that, Plum. I feel like you might have some thoughts on that. Anything you want to add there?
Yeah, I mean, I think the first thing is getting everyone who is making decisions about the system understand that when we're talking about the system with tech debt and the system that's building new features, they are the same system. It is not two parallel systems that we are like trying to competing parties projects. It is the same system. And so we might need to do a certain set of maintenance understanding to be able to build forward the new features. So it's the closer you put those two concepts together, the idea that in order to move something forward, we need to have a certain set of foundations, then you change it from this is tech debt that sits over there on the side and it's in a box somewhere to this is actually something that's sitting on our railroad tracks in front of the train. And we have to move this away from the front of the train before we can actually move forward. So really weaving it in and helping folks understand it is all one set of code that we're trying to work with. At least that's helped for me. Easier said than done, but building that understanding really helps folks get aligned.
Fantastic. Thank you, Plum. If anybody does have any other questions that you want to submit to the panel, please feel free to put them in. It's just in the Zoom Q&A box as well, just as a little nudge. Any other thoughts on that one, or shall we kind of move on again?
Yeah, I can maybe pick up on what I was talking about before with the health versus tech debt thing. And what I really like about it, and I haven't had a chance to try it out myself, but if you think about the principle in SRE, where you have like service level objectives that you set yourself as a team. And when you don't reach those objectives, then it's a clear understanding in the team and with the product and the business side that now we need to invest something so that we hit our service level objectives again, right? So if you think about that architecture health definition as a service level objective that you treat the same way, right? Where you say, okay, as soon as in this particular critical domain area, we hit a point where it always takes us 2 weeks to do a change, then we're not healthy. So now we have to invest. Or, I mean, I'm just making like an SLO up on the fly, right? But I really like this idea of this like common understanding of like, we have a definition of what good looks like. And when we can't hit that, then we have to invest.
I love that. I think that also ties back to some of the other things that we were talking about in terms of kind of getting everybody on the same page, getting that buy-in, knowing that it's going to take a while. So we're on a journey here. Absolutely. Okay, great. Thank you. I've got another question that's come in. I'll just jump over to that one quickly. So it's from Catherine. If you have technical debt that spans across domains of that spans across domains of teams domains. So I think sort of that spans across different ownership potentially. Catherine, correct me if I'm wrong. How do you organize efforts to address it? So just to play that back again, if you've got technical debt, sorry, Catherine just clarified there. If you have technical debt that spans across domains of multiple teams, how do you organize efforts to address that? Any of you got any thoughts on that one? No.
Yeah, maybe we're all quiet because
in?
it's like a really tough problem to solve, right? And I think
Yeah.
everybody has been in this situation, right? I think I mean, usually I can maybe talk about things that I've seen that maybe haven't always been perfect, right? You know, you have some kind of task force, you have to get together and actually plan what you need to do. Everybody needs to be aligned. There are things like when one team is starting to clean something up and they have a lot of dependencies, maybe they do like a request for comments, you know, of the first draft of their decision record, and then they get inputs from everybody. I've also seen approaches where there was important stuff that needed to be done, and there was really like an architect in the organization who had a spreadsheet with like where he was checking the status. Has everybody done this? And, you know, sometimes you need to make plans like this, even if it feels very bureaucratic, right? So yeah, it's like a really hard problem, and I think there's not like the one thing to do. So that's maybe why we were all quiet about it. But yeah, I've certainly seen many of these situations. Yeah.
Yeah, I was going to jump in and piggyback off of that. I think I have 3 spreadsheets open in 3 different tabs right now that are of similar tracking, and they are effective because the main thing is we need, even if it spans across domains of teams, there needs to be some centralized organization mechanism, individual somewhere that is tracking it all, because as soon as it forks off, someone's going to pull ahead of someone else, something's going to get lost, we'll never get all of the way there. So, you know, spreadsheet is not the most sophisticated tracking tool, but it, in a pinch, it really works.
I'm impressed that you only have 3 spreadsheets in 3 different tabs.
Only open now, right now.
Okay.
Not the only ones that exist.
Well, no, my tabs are a lot worse than that. So I am team have all the tabs open. Amazing, thank you. And yes, I am never surprised when there's a bit of a stunned silence in terms of these really gnarly problems that we all know, but actually kind of, you know, being able to tackle them effectively is another matter. Fantastic. We've got a few more questions that I'll try to get to, but I did really want to ask all of you just about the future. So thinking about maybe projects you're working on at the moment, maybe just in a general sense, might not be able to share. The code that we're working on now will inevitably become the legacy systems of the future. You know, I think that we're all in a place where we know that this will be coming at some point down the line. So what are your views more generally or specifically, depending on how you want to answer, about the things that we're creating right now that could become the greatest challenges for us in the future? And is there anything that we could do to perhaps mitigate that? Spark some thoughts for people who maybe haven't thought about this kind of side of it as well. Tom, do you want to jump in first?
Sure. So up until like a couple of weeks ago, I would feel maybe like an angry prophet saying something like, because of all this AI generated code, we have all this new code coming in and it wasn't written by humans, or at least not fully written by humans. So legacy code bases will become legacy much sooner, and they're going to be more of them. Right. So we're the problems that we have with legacy code now, they're only going to exponentially grow. But now it looks like this is happening sooner than expected. And I'm saying that because there are a couple of research papers that went out over the past few weeks, specifically the Dora research. I think it was out yesterday. And it looks like that on the one hand, you're getting code that's higher quality, you know, from groups using stuff like Copilot, GitHub Copilot, and so on. You're getting code that's higher quality, and in terms of documentation, there's better documentation. But what they mean when they say documentation is like inline documentation. Like the comments are better because, you know, these tools are so good with comments, right? But the process of actually integrating this code into the code base becomes longer. And one of the reasons is that there's so much more of it. in a smaller amount of time, and it becomes much more complicated. And not only is it complicated, nobody really fully understands it the way that people understood it before, because they didn't write every letter of it, right? The whole chunks of it were written by Copilot, and then someone went through it. This looks fine. So what ends up happening already is that you're starting to get unintended consequences of things actually taking longer because the code is already becoming harder to understand because there's so much of it and it's complicated. So what's missing here is a really strong context layer on top of the code that's being created that stays connected with the code. That's the only way I think that us humans are going to be able to keep up with all of the new code being generated, at first, co-written with AI, and at some point just written by AI, right? That's the only way. Otherwise, you're going to get more and more code without the explanation of why it was written the way it was and how it connects with the business context, with business logic, and so on.
Fantastic. Thank you. We have had loads of questions come in. Just to remind everybody that if we don't get to them now, we will try and answer them in Slack afterwards. Well, okay, I'm just going to go for one really quick last one. Thank you for people submitting them. I may mispronounce your name. I'm so sorry. Feel free to correct me. Is it Constant or Constant has asked, in the context of legacy code modernization projects, how should the approach be distributed between engineering and product teams? So if we could get a very short answer on that from somebody in terms of that relationship between products and engineering, I'd love to be able to answer that one quickly. Plum, go for it.
I could give a potentially controversial, potentially not one word answer, which is equally, especially at the beginning. I think it's got to be an equal partnership, understanding the functionality, understanding what the application is trying to accomplish, and then understanding the ins and outs of how the application works today and how we want it to work in the future. And I think that partnership continues. Obviously, engineering is going to be doing the code, building the new application, but that continuous partnership is what helps continue the funding of the project, continue the momentum on the project through to completion. I think if those two owners sort of bifurcate at a certain point, then people are moving against different goals, and then it becomes more difficult, and it suddenly feels like we have two projects again versus one set of projects on a more linear track.
I love that. I'm going to have that railway kind of analogy playing out in my head now.
We hit trains today. I don't know why, but I'm going to go with trains.
It's all good. Always happy to talk about trains. And yes, definitely, from my perspective as well, I absolutely couldn't do my job without my amazing product partners as well. So yes, very, very big fan of trying to get all of those conversations into one. Well, I'm so sorry to kind of, be the one to wrap up such a great conversation. But thank you so much, panelists. I feel like this has been really, really interesting. You've had some great insights, loads of practical tips. We'll try to grab any kind of references or anything like that might help you and share them in Slack afterwards. Some of the key takeaways, I think, for me, is that it's interesting when we talk about this, some of the terminology that we use. I think it was Birgitta who talked about kind of legacy. We often talk about that as a good thing, a legacy being left behind, but actually we use that language in a very different way. And the power of language can be super important. So maybe talking about health standards for components, having agreement on what health means, being able to set your kind of metrics around it to know in agreement when you might need to invest in something and when not. I think that is a really powerful activity to be able to do outside of some of the other sort of more standardized stages that we talked about, things like discovery, things like the actual kind of modernization themselves. Having the I got a note here of the worst thing that we can do is to rebuild the thing we don't like in a different language. I think like having the boundaries of what we're trying to achieve is super important. So definitely a big shout out to that. And then in terms of the AI conversation, there's some really, really interesting insights. Thank you so much for sharing kind of different perspectives there, but really understanding the strengths, the areas where it can bring new input. So the example that you gave, Tom, of being able to reverse engineer naming conventions, I think, is a super interesting one. So I guess my challenge to people is to think about the creative ways that perhaps these newer tools can help us with the sort of, the more tricky parts, but within the limits. So thank you again for all of the insights. Thank you to everybody who's joined us and to who's shared questions. Myself, all the panelists are going to head over to the Slack channel now. We will be in the technical strategy channel. I believe in the Q&A, there was a question about how to get into the Slack. So have a look in there if you don't know how to get in. And we're happy to continue the discussion afterwards. So thanks so much for joining, and we hope to see you next time.